It is my pleasure now to introduce Dr. Mathilde Marengo. Mathilde is the head of studies and a PhD supervisor at the Institute for Advanced Architecture of Catalonia, or short IAAC. Her work there focuses mostly on urban phenomenon and understanding current global challenges and how we can address them with technology. She's also head of the Master Studies City and Technology and head of Urban Sciences Lab. She is part of numerous national and EU projects, as well as author of many publications. With that, I give over to you.
Thank you, Milica. Thank you very much for the invitation. It's a huge pleasure for me to be here. I have to say I'm an architect, so I'm one of the normal people, I'd say, in reference to the questions earlier. The work that I'll be showing relates to, well, in some way, the way in which we, within the Urban Sciences Lab at IAAC, but often at IAAC, engage with computation, geometry, and design together. And specifically, I'll be showing some projects that relate to data-driven design and how we spatialize human and non-human behaviors to optimize the urban environment. Just quickly, for those of you who don't know, the Institute is the Institute for Advanced Architecture of Catalonia. We are a research, education, and development center based in Barcelona. We're quite a young institute, founded just over 20 years ago, and fundamentally we work around this concept of innovation and learning from Barcelona itself. We consider ourselves architects of change, and in fact we work within this realm that we call advanced architecture, which is basically the understanding that architecture is no longer just related to the physical space, but also to the digital space. And so this constant interaction between digital technologies and physical spaces enables us to optimize the physical spaces in themselves, optimize the processes with which we produce them, and learn from them in constant feedback. As I was saying, we do a series of different activities, and one of the things that I think is very important of the Institute is that the activities are intrinsically related. So we work in research, development and promotion, and all of these feed one into the other in constant feedback. And we do all of this in order to be able to propose solutions or ways in which we can face the challenges that we have as humanity today. Specifically within the Urban Sciences Lab, which is the research group that I'm directing now, we work on 4 main topics. One is related to urban environments, one to urban justice, one to urban intelligence, and of course urban futures, so where are we going from here? And we do this by integrating social, cultural, technological, and ecological considerations into contemporary urbanization. In general, from the Institute and within the projects that I will show you today, and I perhaps will show 4 if I manage, if not 3, we look at how digital technologies can enable designers to in some way manage what we are designing or the phenomena that we're designing through dynamic, collective, multidisciplinary and multi-scalar perspectives. And we do this with evidence-based processes, but also engaging actively with the creative power and the critical capacity that designers have to understand and project a future of the planet that we're working towards. So the first intersection with geometry, computation, and design that I will take you through is some research that we've been doing around understanding human behaviors in public space. Specifically, we leverage computation in order to be able to do this, using algorithmic thinking in some way to approach the dynamics of our urban environment. So taking inspiration from the urban panopticon, we question a little bit how we might be able to leverage the new technologies that are often deployed into the public space as through engaging with computer vision as something that might be able to help us drive design. I have to say specifically, this research started during COVID, so it started also within our educational formats in a way in which we were enabling our students who suddenly found themselves online, and we as well, to interact and understand the urban environment without actually being able to go into the urban environment. So here we're looking at leveraging computer vision technologies in order to understand what role they might have for the commons. Fundamentally from this, our goal is to understand a little bit how people move in space and understand what are the patterns of occupation of these spaces, but also what are the behaviors of the people, what are the methods with which they use to introduce themselves into these spaces, traverse these spaces, and so on and so forth. And looking a little bit at how much space do we actually occupy in the city. At the time, of course, because of the question of COVID, we were looking at also understanding how people are placed in the space and how we might be able to use this information in order to sort of limit contagion. But it's also interesting to look at how, of course, this might be deployed in other situations where we might need to create more room for more masses. This is something that Barcelona, for example, faces a lot with high levels of tourism in peak moments during the year, but also quite constantly. So fundamentally looking at how we identify these people in space. And the goal of this in some way within 3 spaces, specifically in Barcelona, so we were looking at the MACBA space, the Arc de Triomphe space, and the coastline space, was to understand the rhythm of these 3 different typologies of spaces. So can we determine whether in these spaces there are some certain static elements that are used in a static manner, there are dynamic elements that are used in a dynamic manner, and also an opportunity for us as architects to sort of verify if the spaces that we design are in fact used in the way in which we thought they were designed for. So with this, we were looking into the different spaces. This here is the MACBA. It's a square that's in front of a museum in Barcelona. It's one of the preferred spaces for skaters in Barcelona, mainly because it's one of the only spaces which has smooth surfaces. So the spaces within that area are used in an incredibly dynamic manner because they become elements that the skaters use. This is the Paseo de Arc de Triomphe, again with different sort of urban elements like grass and different types of paving. And then finally the Paseo Marítim, which is used mostly as a transitional space. And actually to the right-hand side, you have the beach there. So the goal, as I was saying, was to experiment and a little bit understand if through the access to sort of video frames, we might be able to determine behaviors or specific behaviors to specific spaces. Specifically, I said specifically about 10 times there. In particular, understanding dynamic and static spaces, but also dynamic and static behaviors, and how these 2 things might correlate or might not correlate, and then how we could use that potentially to design new rhythms of these spaces. So the goal of this research was a little bit to understand the role of, as I was saying, new technologies in enabling us to perhaps understand behaviors that are not understood through top-down processes, but potentially more bottom-up processes. So not having the users know that they are being in some way observed and therefore behaving in a specific way, but rather trying to understand what is the more, let's say, emotional pathway that people use in the city. Of course, as this was part of the work that we were doing in the Master in City and Technology at the time, we also had a little bit of a play on what might this mean in design. So how could we potentially determine or adapt these 3 different spaces to better fit the users who are actually using those spaces, or to change the way in which the users might be occupying the spaces to occupy more of the space, because the 3 spaces have points that are not really used, and how we might adapt those in order to make the space more accommodating to the wider public. Specifically now, in the research that we're doing at the moment, we're looking into how this might enable us to gain a deeper understanding into how gender impacts the way in which humans move in space, in public space. We're looking at developing pipelines in order to be able to bridge the data gap that is present, both on the sort of like territorial or urban scale, but also on the human scale. So a little bit understanding what are the different mechanisms with which we behave in certain typologies of spaces, and how gender, but gender from a perspective of intersectionality, might impact the way in which we use the urban environment. This is something that is in process. There's a lot of work that's showing that, in fact, there is a gender data gap there, and it is something that we wish to tackle in diverse contexts. So I'm just going to throw this out there. If you are interested in collaborating on this topic, please feel free to contact myself or my colleague Isabel at the email addresses that you have there. And with that, I move on to the second topic that I wanted to touch on today, which is architecture generated through material, environmental, I forgot an O there, and human behaviors. So specifically, I'm going to take you through some of the research that we've been doing in 3D printing architecture. This is done by my colleagues, mainly in the robotics lab at IAAC. And the idea or the goal of the work is to negotiate the relationship between the machine, design, and the material, fundamentally integrating sensor feedback, multi-material performance, and the capacity to work with dynamic blueprints within the context of a cyber-physical construction. It's also important for me to say that this research here is actually more than 10 years research now. It's the projects that I will show you started in 2012 and have been building up fundamentally, basically one on the other in order to add different layers of complexity and the capacity that we have to work with this. So back in 2012, we were looking particularly at material innovation or understanding the material of clay. So when we do 3D printing at a large scale in IAAC, we're specifically interested in doing it with clay, with Adobe. And we chose this material, one, because it's readily available where we are, but it's also a sustainable material, and it's a high-performance material in relation to certain aspects of the built environment. So we work with a series of aggregates and additives that are all bio-based and enable us to create a paste that can be deposed through 3D printing technology. What's interesting is that we have the capacity, therefore, to begin to collaborate with different disciplines and understand different scales of the material in itself, and what is the impact of these different scales of the material in the architectural deployment. We've also taken the time to develop, let's say, a series of parameters that are fundamental in order to be able to control the deposition of clay in 3D printing. And so we've hashed out a methodology that we work with our students and our researchers in order to take it to the next scale. One of the other elements that we've integrated, and this here, the project on the left, is called On-Site Robotics. It was designed and actually deployed during a construction fair in 2017, if I'm not wrong, in Barcelona, called Construmat. 2017, on-site robotics. And so basically we printed out this structure during the, I think, 5 days of the fair. And here what we were looking at was integrating sensor feedback. So clay is a natural material, so it's highly susceptible also to environmental parameters, environmental factors. So not necessarily you can print out the same amount of your structure every day, because it will depend also on the humidity, the wind, and other factors. And therefore, it's really important, it becomes really important to have a continuous feedback on how the material is behaving with respect to its environment and how that might impact your printing process on that specific day. So here within a controlled environment, we had the opportunity to test this and understand how we might be able to then create this continuous feedback loop. The Construmat Pavilion was actually printed out with the clay from this here. This here was also printed out with recycled clay. So we've also had the opportunity to ensure that although we have a series of additives within our clay mix, we do have the capacity to crush it down, recycle it, and reuse it in the clay printing. This here was digital adobe, printed out, in 2018, so using the clay from the previous pavilion that you saw there. And this was a 5-meter high wall, printed out in different brick elements. So we printed this out not on site. We weren't on site yet, but within a controlled environment, but already experimenting with the understanding that the geometry, let's say, or how I understand geometry of the building could be optimized to the specific location or the specific environment of a building. So therefore optimizing each of the 4 walls of the building, let's say, to the specific orientation that it has. But of course also not just controlling the deposition of the material, but also the performance that the specific deposition can give us, both in plan, but also in elevation. So how this wall might become a self-shading system to enable certain thermal performances, and then how we can, of course, control in plan the different elements, so more structural elements and elements that are perhaps more oriented towards energy exchange. Of course, when working with clay, it's a material that has a tendency to be quite monolithic, quite heavy. And so one of the other interesting things in engaging with clay in the 3D printing realm is that we can create in some way a lightness. But of course, because of the fact that we're working with additive manufacturing layer by layer, we do have limitation in the sense that we can't go beyond the cantilever that we have unless we have a support. So here we're looking at how we can in some way create perforations, a lightness of the material, but also for the architectural space, the capacity for light and air to circulate within the building. So these are simulations, but also designs oriented to kind of push the limit and understand how we can negotiate the limit, again, according to the environmental parameters that we're working in. Of course, more or less humid climates will impact the capacity to control that, and also within the architectural form that we can or cannot design. It's also very important for us to sort of work with understanding vernacular elements. I mean, of course, we take a lot of inspiration from Gaudí in Barcelona, but not only Gaudí, and understand how these vernacular or traditional construction mechanisms might translate into their deployment with digital technologies. So here we have a series of vaulting systems, and this specifically is also looking at facing the challenge that we have, obviously, with additive manufacturing of the fifth facade, which is fundamentally the roofing system. So how can we cap the building in some way, and then how can we learn from vernacular architecture in order to be able to do that? Of course, vaults are not the only way to go. We can work with embedding other support systems for the printing process. This here was a support system that was designed in order to be able to be placed, and then once the drying is completed, removed, and then reused to continue printing. So the goal of also not generating a system where you create a lot of waste through formwork, but also understanding how we can be ecological or sustainable within that thinking. And then, of course, how this might deploy into an architectural scale. And here, computation becomes essential to understand all of these different complexities, put them together, and enable us to generate a series of different designs. So as I was saying before, we have the goal to in some way customize the architecture. So we're not looking at deploying sort of one-size-fits-all solutions, but understanding very closely what is the environment that we're working with. In that sense, clay is a very interesting material, particularly when you're working with local clay, because all clay is different. So there is always a material testing phase. We are currently working a lot with the clay that we have in our Valdara lab. So we have a campus that is just 20 minutes away from the center of Barcelona, where we have 130 hectares of forest. We have space there. You'll see some pictures of it in a few moments. But basically, we have refined the soil process with that. But here we can see the different facade iterations and how they might look in elevation and in section. As I was saying before, clay is obviously an interesting material because it enables us to work with certain performances, thermal performances, how it has a challenge in relation to, obviously, ventilation. And finally, one of the sort of, let's say, issues, quote unquote, with clay is that it's very susceptible to erosion, either by water or wind. So we look at how we can also embed into the printing mechanisms that can in some way protect or extend the lifespan of the building and control the water flow if it is touched by that. And finally, of course, the interaction also with the humans and how they might engage with the space in itself. So this is what these might look like on an architectural scale, but here we go back to how we're working on a prototype scale and how this might enable us to reduce the impact of the construction site in itself, so working in a very, very, very close loop system, and specifically this is the first architectural iteration that we did in one-to-one scale. It's called TOVA. And here we have a picture of it in our Valdara labs, as I was saying before. This project was completed in 2022. We see it from two different sides here. The timber roofing is enabling the protection of the system from a certain amount of rainwater. And here, of course, how this looks or how this might be iterated into a sort of housing prototype for the Mediterranean. I have a video, but I think I am running a little bit late. But this is the Valdara labs. And that's Barcelona. And this is the construction sites. And I might leave it at that. If you would like to see it, there's a lovely video on the internet narrated by my voice, so you can continue listening to me in that. One of the lovely news around this project is that TOVA won the new European Bauhaus Awards in 2023 for shaping a circular industrial ecosystem and supporting life cycle thinking. So we're very, very happy about that. And of course, the project isn't finished there. So every year we add new layers of complexity and new steps. So here we are printing, TOVA was printed out with the crane, the WASP crane, and here we continue engaging with the WASP crane for this year's pavilion, which, yes, we're still in 2024. 2023's pavilion, Teishit, which was looking specifically at, as you can see, focusing on the question of perforation and transparency and lightness in the structure. I think perhaps I go back here, and you can see the different sort of construction processes, layering of different layers of netting. Teishit in Catalan means to weave, and therefore we have this prototype there. And I will move on to the last section of the talk, which is related to more ecological behaviours and how we can enable connected urban environments. So this scales a little bit up again into tackling questions of planetary urbanisation, but specifically looking at the issue of landscape fragmentation, which is something that is strongly driven by the way in which we as humans manage land, where we divide it into plots that enable us to manage it. So of course, the closer we get to dense urban environments, the more fragmented the landscape is. But as you can see, there is a very high level of landscape fragmentation across the globe. And this goes in complete contradiction with the way in which ecological systems want to work and thrive. So this means that we also need to completely rethink the way in which we design cities and our urban environments in order to enable that to be counteracted or mitigated, but definitely adapted also. So we've been working with a colleague of mine who is an urban computational specialist in order to develop a series of methodologies that enable us to work together with nature or together with nature's needs from the perspective of design. So basically reconsidering the polarization between human or anthropogenic forces and ecological needs in order to sort of embed the needs of nature into our design process. This, of course, isn't something that we thought of. It's something that is strongly embedded into the goals that have been set for Barcelona in the 2021-2030 Barcelona plan. But what we were interested in understanding is how we can determine prioritization of this process in some way. So basically, computer-aided ecological connectivity is a computational pipeline that works with two main inputs. One is related to forest patches and green patches, so the vegetation schemes of these urban environments, and one is related to the road axes or the actual sort of physical environment of cities today. We create a graph which is basically weighted according to the actual street width and streetscape, as well as the vegetation's quality through NDVI. And fundamentally, that enables us to create an enhanced graph that not only allows us to determine where we might want to develop or deploy ecological connectivity within urban environments, but where we actually can deploy these strategies. And by running a series of simulation through a software called CircuitScape, which is an ecological connectivity software that runs based off of electric circuit theory, we are able to determine priorities for the urban environment within which we want to embed ecological connectivity or design for ecological connectivity. This basically, as architecture or architects or territorial planning, territorial designers, enables us to negotiate the very large ecological scale together with the actual scale that we deploy design solutions at, and therefore understand how these two scales feed one into the other and enable for healthy ecological systems. So this is a very light map of Barcelona. This is the coastline here, and the blue triangles are the urban green pockets. The red squares are the forest patches. Valdaura sits somewhere up here. I'm sorry, it's very light. But here we see a little bit heavier. So here we've run the scenarios looking at how the current scenario seems and what the potential scenario would be if we implemented more ecological connectivity. As you can see, the out to in is not very strong in Barcelona, of course, because the ecology wants to stay in the forest, doesn't want to go into the city. The in to out becomes stronger. And basically, we overlay these two maps in order to determine what are the priority spaces within which we want to work. And so here we are able to determine, based on the feasibility of if we actually can or cannot deploy ecological design approaches in these specific areas in Barcelona, which are the ones with top priority or low priority for the health of the greater ecological system. So again, this capacity to be able to negotiate between the different scales. We did all of this based off of local data, but we were also interested in understanding if this might be something that we could do through remote data. So we ran a little bit of some tests with OpenStreetMaps and Google Earth Engine in different cities, Berlin, Madrid, Milan, and of course, Barcelona. And we're able to a certain extent, be successful there. Of course, the ideal thing is always to work with local data in these situations because we are trying to determine the feasibility, so the actual geometry of the space that you're working with is very important. But what this does enable us to do is in some way determine different spaces where we should definitely go and create or do some local data sourcing campaigns. How am I doing for time? Bad? Okay, bad? Bad, okay, that's it. Boom. I will leave it at that. This was, okay. So computation is a platform to critically think. Ecology is also a way to think, but also to embed collaborative processes in our, the way in which we design, and also regenerative behaviors. And finally, communities are also essential. The community projects, you didn't really see it, but I'd like to take a second to thank all of my colleagues at IAAC who collaborated in these projects. This is obviously not just my work, and thank you for your attention.